Lesson 5-6, Angle Bisectors and Perpendicular Bisectors. This is a very straightforward lesson, not a lot of tricks to it. First off, what's an angle bisector? We have an angle, we'll label it, and a bisector goes right down the middle. So it could be a ray, it could be a segment, it could be a line. And we know it's congruent because of that. Well, it turns out that if you draw a perpendicular line from the ray to a point, we'll call it D, then we end up with two congruent triangles. This is basically angle, angle, side. So if they're perpendicular and they meet at the same point, by CP/CTC we know these would be equal. So if this was 3 feet, this would also be 3 feet. So that's very simple angle bisector. I mean, you can just say triangle ABD is congruent to triangle ACD by angle, angle, side. And then we get all these problems that AD is a bisector. What's distance BD? What's distance DC? Oh, they're equal. That's it. And another way to put it is that a point on the angle bisector is equidistant from the two sides of the triangle. And this is how we say they're equidistant. These two are the same distance. The distance has to be drawn perpendicular. Otherwise, it's not the smallest distance. That's a theorem in geometry, but we'll get to that another time. And as I just showed, it's because they form two congruent triangles. I really don't get into the details on this. All I want you to know is they're two congruent triangles. Therefore, you know, this matches up with that. It's pretty straightforward. So now, same idea with a perpendicular bisector. We have lots of points I'll use here. And then we run a perpendicular bisector down the middle that's at a 90-degree angle. And we say that any point on the perpendicular bisector is equally distant from the ends of, actually this should be a segment, my bad, from the ends of a segment. Remember, it's perpendicular, 90-degree bisector. So we get that. Then we have this by reflexive. Let's give this one a couple names here, H and J. So we say that triangle FHJ is congruent to triangle GHJ by side angle side. So FJ is congruent to GJ by CP/CTC. All nonsense. I don't really care. Here's a problem. If this is 3x plus 4, this is 2x plus 8, we just set them equal. Because we know we have two congruent triangles. I don't need to know all this. It's not a bad thing to know, but what I really want to know is that I have two congruent triangles and I can match up the pieces. So we do a little algebra. X equals 4. One of the big problems people have with these is that they forget this is a whole side. So if I say, you know, what's the distance from FJ? Well, then we got to plug it in. 3 times 4 plus 4. FJ equals 16. Now I was going to do some example problems on this, but they all pretty much look like that. So that's the standard kind of problem you're going to see. That's really it. Good luck.